Okay, here we're going to deal with longs and latitudes in a Mercator chart. So we visualize around Earth, and what we've had to do with that is we've had to put it on a flat piece of paper. Okay, so effectively these areas around here and here and here and here end up being flattened out, so they're all obscured. Okay, so now if we take our round Earth and we put it onto a Mercator chart, and we take our zero line down the middle, which is known as universal time, can also be known as Greenwich Meridian time, and somewhere along the line it was also known as universal coordinated time. But pretty much from the zero line heading east, we have longitude lines that go up to 180 degrees east, and we have the other direction west, 180 degrees. These lines join up basically, not the neatest drawing around, but if you can visualize, these are what we call longitude lines, starting at 0, going to 1, 2, 3, 4, all the way until we get up to 180. In other words, 360 degrees all the way around, going that way around. We then, those are our longitude lines. We then look at latitude lines. So we either have 0 as the equator, or going up to 90 degrees north, or going down to 90 degrees south. So these lines are cut perpendicular to each line straight. So when it comes to measuring distance, we always measure on this scale. We never measure on this scale because it's all distorted in these areas. Okay, now I'm just going to clean that up and then we can carry on. Okay, so let's just okay, so if you can visualize that chart being our piece of paper with our longitude lines running straight and our latitude lines running across, each cutting itself at 90 degrees. So it's 0 to 180, or 0 to 180 west or east, and it'll be 0 going to 90 north or 90 south. So if somebody tells me they are at this position over here, and that position happens to be, say, 18 degrees south, and say, let's make it 15 degrees east. Okay, I can take those coordinates and I can plot them straight on that little mark over there. The next person may tell me, well, I'm on exactly the same longitude line. Okay, so I'm somewhere along, oops, okay, so I'm somewhere down this line, okay, which happens to be halfway. So I'm still 15 degrees, but I'm now east, but I'm now 18 degrees 30 minutes south, okay, because I'm halfway now. Okay, so from that I can actually deduce that I'm 30 nautical miles away. Okay, let me explain that in a bit more detail. 1 nautical mile equals 1 minute. Okay, we need 60 minutes is equal to 1 degree. Okay. 1 nautical mile is equal to 1,852 meters. But in nautical terms, we don't say we are 15 degrees east and 18 degrees 30 minutes and seconds. We work in decimals. So if I was now, for example, maybe I was possibly not quite on 30, but I was slightly out, and I was halfway between 30 minutes and 31 minutes, I would not say I was 30 minutes and 30 seconds. Okay, that's incorrect. I would have said 18 degrees 30.5 minutes south. Okay, so it's important to understand we don't use seconds. These decimal of a minute is known as a cable. So if you think about it, 0.1, 0.2, 0.3 is equal to 1 cable, 2 cables, or 3 cables. Okay, so hope that helps. If you got any questions, give me a shout.